Alright, so let's put our heading. And this is G 31.159. Okay. Now, let's write down our problem. In the diagram, of triangle ABC below, segment AB is congruent to segment AC. The measure of angle B is 40 degrees. Okay? And the question is, what is the measure of angle A? Alright, and then it gives us 4 choices. The first choice is 40 degrees. The second choice is 50 degrees. The third choice is 70 degrees. And the fourth choice is 100 degrees. Alright, and then what they do is they give us a picture of a triangle. So I'm going to make this side about 1 inch. It's a little slanted. 1.5 inches I'll make it. Alright, you're just going to make it something similar to what I'm drawing right here. I'm going to make this side about 1.5 inches also. And then connect the 2 ends here. Something similar to that. And this is C, A, B. Okay? So, here's what's going on here. In the diagram, AB is congruent to AC. Segment AB is right here. So, this is congruent to AC, which is over here, to this. Those lines mean that these two segments are congruent. If I have one of these lines here and one of them here, it means that these two lines are the same length. We don't know what the length is, but we do know they're the same. Okay? The measure of angle B is 40 degrees. Let's put that into our diagram. Alright? What is the measure of angle A? Okay? Hopefully you noticed that this is an isosceles triangle. Okay? An isosceles triangle has 2 congruent sides. These 2 angles, alright, are called the base angles. The angles that are opposite the congruent sides are called the base angles, and they're also congruent. So they told me B was 40, and since B is 40, I know that C is also 40. Okay? What they want to know is the vertex angle. This is called the vertex angle up here. And the vertex angle, we'll just call it X degrees for now. So, now we can just use the fact that all 3 angles add up to 180 to solve for X. So we have X plus 40 equals 180. x plus 80 equals 180. Subtract 80 from both sides, and x equals 100 degrees. So choice 4 is correct. Okay? Now, let's do the problem that you're going to solve on your own. So in the diagram, of triangle DEF, below, segment DE is congruent to segment DF. The measure of angle E is 55 degrees. What is the measure of angle D? Okay, there's our question. There's no choices. Now let's draw in a triangle. So you're going to make your triangle look similar to this one. Okay. And I'm going to label this D, E, F. Now, DE is congruent to DF. So DE, this one, is congruent to DF, this one. So here's my isosceles triangle. If you want to put it straight side up, it's like this. Okay? Now it says angle E is 55 degrees. Alright, remember the angles that are across from the congruent sides are congruent. They're called the base angles of the isosceles triangle. So if E is 55, I know that F is 55. Okay? What I'm looking for is D, so let's call that X. So now I just solved this problem. X plus 55 plus 55 equals 180. X plus 110 equals 180. Subtract 110. X equals 70 degrees. Okay. Wasn't supposed to solve that one, so I'm going to go ahead and fix that. Alright, on the next sheet, let's put our heading. This is G 31.160. Okay. in triangle ABC, segment AB is congruent to segment BC. An altitude is drawn from B to segment AC and intersects segment AC at point D. Which conclusion is not always true? Okay, and the options are, one says angle ABD is congruent to angle CBD. Number two, angle BDA is congruent to angle BDC. Number three says segment AD is congruent to segment BD. And number four says segment AD is congruent to segment DC. Alright? Now, there's no picture, okay? So, what we have to do is draw a picture. That's what I would do. Okay? So that's what I'm going to do. I'm going to draw a basic picture of a triangle. I'm going to make each side, I don't know, about 2 inches, so it's not too big. Okay, and this is ABC. And it says AB is congruent to BC, so we know that AB and BC are the same length. So I'll put a single hash mark on each side. Since those two are the same, I also know that the angles that are opposite them are the same. So I'm going to put an angle mark here and one angle mark here. That means that these two angles are the same even though we don't know what they are. This is an isosceles triangle. These are the base angles and these are the legs. Now, an altitude is drawn from B to AC. An altitude goes from B straight down to AC. Okay, that's an altitude. So let's label that altitude. The altitude goes from whatever point they say straight down to the bottom. Okay? And intersects AC, which is this side, at D. So that means it intersects AC right here, so they want us to label that D. Which conclusion is not always true? Okay? Now, when an altitude in an isosceles triangle comes down from the vertex, this is the vertex angle. When you draw an altitude down in an isosceles triangle, it cuts this angle in half, it bisects this angle. So this angle, this little angle right here, and this little angle are congruent. So I put 2 angle marks on each one. So this one and this one are congruent. And I also know that this little side right here, AD, is congruent to this side over here, DC. It also bisects this segment. Okay. Now this happens in only isosceles triangles or equilateral triangles. Otherwise it doesn't happen. Now let's look at our choices. We want to see which one is not always true. ABD, angle ABD, that's this little one on the left, is congruent to CBD. CBD, that's the little one on the right, and we know those two are congruent. BDA, BDA, by the way, this is a 90-degree angle, right? And so is this one over here. That line comes straight down to the ground, forms a 90-degree angle. So this says angle BDA is congruent to angle BDC. Well, that's true. They're both 90 degrees. Number 3 says AD is congruent to BD. AD is right here. That's not congruent to BD, right? It could be, but we don't know that for sure. Okay? We know that AD is congruent to DC, which is the 4th choice, so we know that's not an option. So the only choice could be choice number 3. Okay? So, alright, so we're going to go on to the next example. I'm not going to give you a checkpoint for that one at this time. Put our heading again. G 31.161. Okay. So, let's do it. An isosceles triangle, so they're telling us right away that it's isosceles. An isosceles triangle ABC, and they're giving us the name. They're saying that AB, side AB, is equal to side BC. Then they want to know which statement will always be true. And we're given 4 choices. That the measure of angle B will equal the measure of angle A. That the measure of angle A will equal, not equal, is greater than the measure of angle B, that the measure of angle A is equal to the measure of angle C, and then that the measure of angle C is less than the measure of angle B. Now I just want to give you a word of warning to be careful with your angle signs and your less than and greater than sign because they look similar, right? So just be careful when you're reading a problem. Make sure that what you're looking at is an angle sign and not a less than sign. Okay? So, we have isosceles triangle ABC. We're just going to draw this one by hand. Okay? A, B, C, and AB is equal to BC, so they get 1 hash mark each. We also know that angle A is equal to angle C because those are across from the congruent angles, from the congruent sides. Whenever you have two congruent sides of a triangle, the angles that are opposite those sides or across from those sides are always the same. Okay? And the reverse is also true. If you have two angles that are congruent, then the sides that are opposite them are also congruent. Okay? So let's see. The measure of angle B equals the measure of angle A. Well, we don't know that for sure. It could be true, but we don't know it for sure. The measure of angle A is greater than the measure of angle B. We also don't know that for sure, right? It might be, but it might not. It might be the same even. The measure of angle A is equal to the measure of angle C. That we know for sure. These are the base angles, and they're opposite the congruent sides, so we know that those are the same, so it's choice 3. Okay? Take out another sheet. Let's put our heading. And this is G 31.162. Okay, so let's see. If the vertex angles of two isosceles triangles angles of two isosceles triangles are congruent, then the triangle must be, choice 1 is acute, choice 2 is congruent, choice 3 is right, and choice 4 is similar. Okay? So, then the triangles, this says triangles, I forgot an S there. The triangles must be. So here's what we have. We have two isosceles triangles. Right? And let's make these the sides that are congruent. Now, if these are isosceles triangles, right? And we know that these two sides are congruent, then we also know that this angle is congruent to this angle. Alright? And let's make this side with 2 marks on each one of these triangles, because we know on this triangle that these two are the same, but we don't know if they're the same as this triangle. Okay, so if this triangle has 1 mark, then this one should have 2 marks until we know that they're both the same. Then we can put 1. Or we can put 2 on this one. And in this triangle, if it's isosceles, which they say it is, we know that the angles opposite those sides are congruent. So I already used 1 angle mark for this triangle, so this time I'm going to use 2 angle marks on this triangle. Now, what they say is that the vertex angles of these 2 triangles are congruent. So, now I already used 1 mark and I already used 2 marks, so the vertex angle is the other angle of the isosceles triangle. Okay, these are the base angles, and this is the vertex angle. So it says the vertex angles are congruent. So I'm going to put 3 angle marks here and 3 angle marks here, because I know that it tells me that these 2 angles are congruent. Okay? Well, if these 2 angles are congruent, then these base angles also have to be congruent. It's impossible for them not to be. Just to give you an example, if this vertex angle right here, say it was 80, then we know that these 2 angles together would have to be 50 each, because 50 plus 50 plus 80 is 180. And if this angle is 80, which it says it's the same as this one, 80, these 2 angles also have to be 50 and 50. So we do know we can add another angle mark to this angle and to this one, because we know now that the base angles must be the same. Okay? But just because the angles of 2 triangles are the same does not mean it's congruent. Okay? All the sides have to also be the same, but we don't know that for sure. All right? Because you can have 2 triangles that have all of the angles the same, but have different side lengths from each other. Okay? So, what that means is the triangles are similar. Similar triangles. In similar triangles, all of the angles are the same. Okay, and the sides don't have to be, but all the angles have to be. And that's what we have in this problem. Okay? Now, take out your next sheet. This problem is GG 31.163. Okay, in the diagram below, triangle LMO is isosceles with LO equal to MO. If the measure of angle L equals 55 and the measure of angle NOM equals, whoops, not 20, 28, what is the measure of angle N? Number 1 is 27. Number 2 is 28. Number 3 is 42. And number 4 is 70. So that, and then we have a picture, and this is what it looks like. We're going to draw this by hand. Okay, let me move this up a little bit. We have this triangle, comes across like that, comes down like that, goes over like this, and then has another line here. And this is L, M, N, O, and this is 28 degrees. So, this is the picture they gave us. Okay? Now let's look at our information. LMO is isosceles with LO equal to MO. So the two isosceles sides are LO and MO. Okay? So we do know that that angle and that angle are going to be the same. Alright, we don't exactly know what it is yet, but we know that they are going to be the same. Now, if the measure of angle L is 55, so now we know L is 55 degrees, so that means we know this angle right here is also 55 degrees. They also tell us that the measure of angle NOM, that's this angle, is 28. Alright, they already filled that one in for us. So, they want to know what is the measure of angle N. So let's put an X here. Okay, now, let's find our angles here. If this is 55 and this is 55, we can find this angle right here, right? Now, we don't need to for this problem, so I'm not going to. Alright, because we need to know this angle, which is a part of this this other triangle. In fact, we are going to find it because we could solve this another way. So let's find this angle first, since we know how to. Okay? We can do, make sure you can see this. We can do Y. I'm going to call this angle Y. So Y plus 55 equals 180. Y plus 110 equals 180. Subtract 110, and what you get is Y equals 70 degrees. So this is 70. Okay? Now, we can also find, let's call this Z right here. Angle Z. Now, these two angles that are right next to each other, these two angles form a straight line, right? We have the first angle is 55 degrees, which is this piece, and then we have Z on this side, so these two angles form a straight line. They're called a linear pair. And what we know about linear pairs, or straight lines, is that the angles must add up to 180 degrees. This whole angle must be 180 degrees. Okay? So I can do Z. Don't make your Z's look like 2's. Alright? Put a little thing in the middle of it, as a matter of fact, to make sure you know it's not a 2. Z plus 55 must equal 180. Subtract 55 from both sides, and we get Z equals 125 degrees. Now we can fill that in our diagram. So far we've found every angle except for the one that we want. But you needed to find Z, right? Because now you can find, because you know that these three angles of this triangle have to add up to 180, and if you didn't know this one, then you couldn't use that rule. You need 2 out of the 3 angles. Now we can do x plus 125 plus 28, so we're looking at this smaller triangle here, these 3 angles, and that must equal 180. So that means that x plus 153 must equal 180. If we subtract 153 from both sides, what we get is that x equals 27 degrees. And that is the angle that they're looking for. So our answer is choice 1. Okay. Next sheet. Now we're on GG 31.164. Okay? So, we have in the diagram below of triangle ABC, segment AB is congruent to segment AC. The measure of angle A is 3x, and the measure of angle B equals x plus 20. And the question is, what is the value of x? And here's what our picture looks like. And you got to draw this. Goes up like that, comes down like this, goes like this, and we have B, A, C. This is 3x degrees, and this is x plus 20 degrees. Okay, let's look back at our question. AB is congruent to AC. AB, that's this segment, is congruent to AC. That's this segment. So this is an isosceles triangle. Okay? And we know that in an isosceles triangle, the base angles, which are the angles that are opposite the congruent sides, are congruent. So if this is x plus 20, then we know that this is also x plus 20 degrees. That helps us because now we can write an equation that adds all of these angles up and sets them equal to 180, right? Because all the angles in a triangle add up to 180. Ooh, let's put there's choices for this problem too. Let's put them on the right. Choice 1 is 10. Choice 2 is 28. Choice 3 is 32. And choice 4 is 40. Alright? We're going to solve this problem below the diagram. So 3x, that's this angle, plus this angle, which is x plus 20, plus this angle, which is x plus 20, equals 180. Now we have 3x plus another x is 4x plus another x is 5x. And then we have a positive 20 and another positive 20, so that's positive 40 or plus 40, and that equals 180. Then we subtract 40 from both sides, and we get 5x equals 140. Then we divide both sides by 5, and we get x equals, 5 goes into 14 twice. 5 times 2 is 10. When we subtract 10 from 14, we get 4. And then we have a 0, so it's 40. And 5 goes into 40 8 times. Okay? So x is 28. Now, what are they xing us for? What is the value of x? X is 28, so we're done. We can just come back here and box off our 28. Okay? So, next problem. G 31.165. Okay. In the diagram below of triangle ACD, okay, comma, B is a point on segment AC such that triangle ADB is an equilateral triangle and triangle DBC is an isosceles triangle with segment DB congruent to to segment BC. And they want us to find the measure of angle C. Okay, this is not multiple choice. So, here's what we do. Well, first we draw the picture, okay? This is the picture they gave you, so this isn't something you're going to come up with on your own. Alright, so it comes up like this, and it goes out like that, and this part comes down like this, and then we connect across the bottom like that. Okay? And we have A, D, B, and C. Alright, that is what the problem is. Now, let's start labeling what they give us. So, in triangle ACD, that's the big one, B is a point on segment AC, here's B, it's a point on segment AC, such that triangle ADB, that's this one right here, okay, right here, this little one on the left, is an equilateral triangle. In an equilateral triangle, all three sides are equal, so I'm putting one mark on each side to indicate that they're all equal, and all of the angles are 60-degree angles, so I'm putting that in right away. Okay, and this is the case for all equilateral triangles. The angles are all equal at 60 degrees, and the sides are all equal. Now we don't know what the sides are yet, but this is what we have so far. Now it says, and triangle DBC, that's this one on the right here, is an isosceles triangle. So this one on the right is isosceles with DB, that's this side right here, being congruent to BC. So if DB and BC are congruent and DB has one hash mark, then BC should also have one hash mark. Alright, so really we know that all four of these sides are all the same length, these four segments. Okay? Now they want us to find the measure of angle C. Let's put an X there. Okay? Well, remember that in an isosceles triangle, the base angles, which are the angles that are across from the congruent sides, are also congruent. So if this angle is X, this angle also must be X. Okay, now I have two angles of this isosceles triangle that I need to solve for, but they're both the same. Now if I figure out this third angle right here, I'll be able to add these three angles up and set them equal to 180 and solve for X. Okay? But I need this angle to do that. Alright, now we can find this angle, let's call it Y. We can find that angle because this down here is a straight line, and straight lines have an angle of 180 degrees. Okay? These two angles are a linear pair. They add up to 180 degrees. They form a straight line. Alright? If I start here and I go through the one angle and then through the second angle, I form a straight line. That's 180 degrees. So, I can say that Y plus 60 equals 180. Subtract 60 from both sides, and I get Y equals 120 degrees. So this angle is 120 degrees. Okay? Now I can set up my next equation. I know that X plus 120 equals 180. X plus 120 equals 180. So 2x plus 120 equals 180. Subtract 120. 2x equals 60. Divide by 2. X equals 30. So I know that this angle is 30 because it's x, and I know that this angle is 30 because it's also x. And these are the base angles of this isosceles triangle. Okay? Normally this isosceles triangle, if you're drawing it, would be, would be drawn like this. It would be flat on the bottom here, and these would be the base angles, and this would be the vertex angle, and these would be the congruent sides. But this isosceles triangle, it's on its side, and it's okay. The triangle is allowed to rotate around. Alright? So, let's write a little thing here. So since the measure, they're asking us for the measure of angle C. See, it says find the measure of angle C. So the measure of angle C equals x, right? Which equals 30 degrees. Okay? Next problem. Okay, let's put our heading. Um, 27, 13. Flug, and this is G 31 point, and we're on 166. There's this one and one more problem in this GG31 section. Okay? So this is the second to last problem in this section here. So in triangle RST, the measure of angle RST equals 46, and segment RS is congruent to segment ST. What they want us to do is find the measure of angle STR. And there's no diagram, so we have to draw our own diagram. Okay? So we draw an isosceles triangle looking thing. And we want these to be the congruent sides. Okay? So it's RS and ST have to be congruent. So S is going to be up here. That way I have RS and ST. I mean, it doesn't have to be this way, but then you're going to have, this is that you want to always draw your isosceles triangles with the two congruent sides here, not on the bottom. I mean, you can, but it just makes it a little bit more complicated to look at. Okay? But if we did do that, we could always just turn our page if we had to. Alright, but it's just better to do it this way. So, RST, the measure of angle RST, that's this angle. The S is where the middle of the angle is. It's 46 degrees. Okay? Now, find the measure of angle STR. STR. So let's put an X there. Now remember, base angles, or the angles that are opposite the congruent sides of an isosceles triangle, are congruent. So if this is X, this is X. So what we do, like usual, we do X plus 46 equals 180. They all add up to 180. So 2x plus 46 equals 180. Subtract 46 from both sides and we get 2x equals 134. Divide both sides by 2 and you get x equals, let's see, 65 and 65 is 130, so then we add 2 more, so 67. Okay? Now, the measure of angle STR, because that's what they're asking us for, find the measure of angle STR. STR, it's this angle with the x, is equal to x, so it's equal to 67 degrees. That's what we found. Okay? One more. This is G 167. Whoop. GG 31.167. Okay? So let's write down the problem. In the diagram below, of triangle GJK, H is a point on segment GJ. That's the first piece of info. And then it says segment HJ is congruent to segment JK, and it says the measure of angle G equals 28, and the measure of angle GJK equals 70. It says determine whether triangle GHK is an isosceles triangle and justify your answer. And it gives us a picture that looks like this. Okay, and it says it has G, K, H, and J. And the 28 is labeled for us, and so is the 70. Alright, now let's go through this problem. In the diagram below of triangle GJK, GJK, that's the big triangle, okay? H is a point on segment GJ, here's segment GJ, and H is a point on that segment, so that's what it is, it's a point there. It intersects it at a point. HJ, this segment, HJ, is congruent to JK, to this segment over here. Okay? The measure of angle G is 28, they labeled that, and the measure of angle GJK, that's this angle, is 70, they labeled that for us. Determine whether triangle GHK, that's this one over here on the left, is an isosceles triangle and justify your answer. Okay, so let's start solving this problem. Now, let's look at this isosceles triangle over here on the right side. Right? It's got two congruent sides, so that means that these two angles are congruent. So let's call them both X for now. I'm just going to shorten that arrow so when I figure out that angle I could put it in there. Okay, let's solve for those two angles. And we can use this triangle on the right here and the fact that we know that all three of these angles must add up to 180. Okay, so we know that X plus 70 equals 180. Let's subtract, actually we could do that first. Let's subtract 70 from both sides. So now we have X plus X equals 110. X plus X is 2X, so 2X equals 110. Divide both sides by 2. X equals 55. So we know that this angle is 55 degrees, and so is this angle, 55 degrees. Now, it's okay what I did here, but really we should have combined like terms first. So we should have first said 2x plus 70 equals 180, and then subtracted 70, but it doesn't really change anything. Alright, but it is correct. It is more correct to simplify, to combine like terms first. Okay, so I should have done that first, but it still works out the same. And it is still correct. Okay? You wouldn't lose any points for this on the Regents exam. This would be fine. Alright, now, let's call this angle Y. Again, these two angles right here are a linear pair. They add up to 180 degrees. Alright, I'm just going to move my 55 a little bit so it doesn't look like it's part of that X. Okay. So, these two angles add up to 180. They form a straight line. And a straight line is always 180 degrees. So we know that Y plus X, but we know X is 55. So Y plus 55 must equal 180. Subtract 55 from both sides. Y equals 125 degrees. Well, we don't have to put degrees here, but when we label our triangle with the 125, we'll put in the degrees. Okay, now, we're almost there, right? Let's call this right here angle Z. Let's figure out what that angle is, and then we'll be able to determine whether this triangle on the left here is an isosceles triangle. Angle Z we can find by adding these three angles and setting them equal to 180. So Z plus 28 plus 125 equals 180. So Z plus 125 and 28, that's 153 equals 180. Subtract 153. So then we know that Z is 27. So, wow, that's close. Z is 27 degrees. So it says determine whether GHK is isosceles. It's close, but it's not, right? Two of the angles would have to be the same in an isosceles triangle. So let's justify our answer. Triangle GHK justify means you have to write a sentence or a paragraph explaining why the answer is what it is. So we're saying triangle GHK is not an isosceles triangle because all of the angles are different. And that's good enough. Now there's other things we can say, but I believe that would be the simplest one. Now let me just look up one thing real quick. This was problem 167. Just checking something. Let's see. Okay. That's it. That's all you have to write. So that is the end of that problem and the end of GG 31 problems which deal with isosceles triangles.